of Sana Jones, and I worked a bit with Mega Sundara too. Yeah. So mostly doing prosody perception stuff.
I probably met you at one of the Bruce Hayes things, but I have bad memory, so.
Oh yeah. I'm not sure. I was trying to remember myself. I think I saw you in Seoul, Korea 2 years ago.
Oh yeah, that's right.
Hong Kong. Yeah, it feels like a lifetime ago.
I know.
Right, but yeah, I was there. Was 2019? Yeah.
Yeah, I was hoping to go again in 2020, but.
Yeah, me too.
Gosh, that was 2 years ago. That's crazy.
Yeah, that was a fun conference. I really liked it.
Yeah. Fun. I'm hoping. I mean, we'll see. COVID willing, it'll get started up again for next year. Yeah.
Something that I found kind of strange about this conference is that when you log in to any talk that's in this room on any day, they put you in the panelist category.
Oh, right. I was really confused about that.
Yeah, the first time I logged in, I was like, wait, I'm on the panelist. Wait, this isn't what. Did I have the date wrong? And then I finally know it's okay. There's way too many panelists, and all of them are people who at some point talk in this room. So, you know.
Right. Right. Yeah, I was really. I figured that had to be the reason why, but I was still not sure. I'm very confused.
Okay. We have another 2 minutes to wait until people are let in entirely. we're gonna have to start soon, but I don't see that many people coming in yet. I'll wait until it's 2 or 5 or 3, depending on where we are. 4. Okay, I can see people coming in. Okay, so it is actually time. So I'm just going to say, well, first of all, welcome to our first session, oral session, Prosody I, Part 1. Good afternoon, good evening, depending on where you are. I'm on the East Coast. So I'm Maria Paula D'Imperio, Rutgers University. So we have 3 papers in this session. As you know, you are allotted 20 minutes for the presentation and then 10 minutes for the questions. And for the attendees, please, when we're gonna go to the question part, can you please put your question either in the chat box or, and I even prefer that, raise your hand so that you can ask the question yourself, okay? I think it's gonna be even better. So I'd like to start with the first talk, which is an acoustic analysis of Ho-Chunk accent and boundary tones by Cameron Duval and Nancy Hall, which is gonna be given by Cameron Duval, California State University, Long Beach. Oh, you have to unmute yourself, Cameron.
Okay, sorry about that.
Yes.
Okay, hello everyone. So Dr. Nancy Hall and myself are going to be talking to you guys about our acoustic analysis of Ho-Chunk accent and their boundary tones. So to start, as a little bit of background, so the Ho-Chunk language is a Siouan language spoken mostly in Wisconsin and Nebraska. And in previous literature, it's been spelled several different ways and also previously referred to as Winnebago. It is an endangered language with fewer than 200 speakers, all of which over the age of 60. So as for Ho-Chunk accent itself, it's quite a unique system. It is what's considered Mora counting and syllable accenting. So in words, in Ho-Chunk words, the first accent will fall on the syllable that contains the third Mora. And how we determine how many moras a syllable has is based on whether it's a light or heavy syllable. So a light syllable, which is denoted with an L in this study, is essentially just comprised of a short vowel and will be comprised of 1 mora. On the other hand, long vowels and diphthongs will be denoted as an H for heavy syllable, and these are worth 2 moras. So examples of these accentual patterns we can see in some examples of Ho-Chunk. So for example, like in the LLL example, so in the light trisyllable. Great, and then seen in a light, heavy, light second syllable accented example. Sorry, I'll play that again. Great, and then lastly, a pair of 2 heavy syllables together in 1 word. Great. So because of its a very different nature, this accentual pattern, it's been studied dozens of times in past literature. The only thing is that these studies really have to do with impressionistic data and not really any acoustic studies of how the accent is really accentualized or really how it's realized in the word and how it has to do with intonation, and more just about the placement and the phonological theory behind these accents. So the goal then of this paper is then to provide the first acoustic description of these Ho-Chunk accentual systems and their boundary tones in isolated words, and also to address and to touch on some of these more disputed aspects of secondary accent, which has also been argued in past literature. So as for overall data collection, tokens were taken all from the corpus of Kenneth Miner's fieldwork recordings from the mid-70s. Most of the words were from one female speaker, and they were spoken in isolation, but there was occasionally a male speaker, and we'll get to that later. Prot and Perl scripts were both used to both extract and to also automatically categorize the words based on their shape. So like we see before, when we see LHH, LHL, LLL, that would automatically categorize them into these shapes. Although once they're categorized into those shapes, they were then manually listened to and manually categorized based on the placement and the intonation of their accent. And then after this categorization, vowel boundaries were then marked in Prot, and then a script was used to read the pitch readings, or to read the pitch of each vowel in 6 different places. These pitch readings for each shape were then averaged and then graphed. It's also important to note that in this study, even though we have L's and H's, we have long and short vowels such, we do not really, we normalize the lengths in our graphs. So we don't really denote them as being different lengths. And it doesn't really seem to be an issue when we get to the actual graphs. So as for the actual pitch patterns observed in the different shapes, so our first shape would just be normal H. So monosyllabic words in Ho-Chunk are always heavy. They're always either a long vowel or a diphthong. And we see that within this accented syllable, it starts both, they're both realized with a high pitch accent, while in the falling intonation, we see a low boundary tone. And then in the non-falling intonation, we see a high boundary tone being observed. And this can be exemplified by the 2 different intonations produced by the same word. For example, no, which would thus be produced in the falling intonation. But then sometimes because of certain intonational properties of the elicitation, and also often if, for example, if a word was spoken in the middle of an English sentence, it would result in a rising or a non-falling intonation, such as this. No. And these 2 different falling and non-falling intonations are seen in a lot of polysyllabic examples as well, which we'll get to. As for pitch variation between different speakers of H, so like I said before, a male speaker occasionally spoke in the elicitation corpus, but not to the extent where we can get male and female variations to a very certain, to a very certain degree for every single shape. But for monosyllables, we actually did have enough tokens to compare the male and female speaker. And we see that while there is a general trend of just a high pitch accent and a low boundary tone in accented monosyllables in isolation, we see that the absolute apex, or the highest tone of the pitch accent, seems to be realized slightly after the beginning of the word, slightly after the elicitation of the word with the male speaker, while with the female speaker, its highest point of the pitch seems to be in the very, very beginning of the word. So now moving on to disyllables, as we see again in the second syllable here, which is the accented syllable, we do see a general trend again of high pitch accent, low boundary tone, as we see with accented falling syllables. But then we also see the first syllable, more specifically the first unaccented syllable, to have a mid boundary tone. And this is a trend that we'll see with many of the polysyllabic shapes. And you can see here notice how we are comparing several shapes, both with L's and H's in different combinations, and yet a similar trend in pitch pattern seems to arise. So that's why we didn't find much of a problem with normalizing vowel length in our graphs. Still comparing disyllables, now just comparing 2 different intonations of 2 different variations of this shape. We see again the similar trend of starting with the mid-boundary tone and then starting off the accented syllable with a high pitch accent, but the non-falling examples will have a high boundary tone as opposed to a low boundary tone in the falling disyllabic examples. We see again a similar overlay of these accent patterns in trisyllables of different L and H combinations. While instead of where we see a mid boundary tone, high pitch accent, and low boundary tone, but since there are now 3 syllables, the high pitch accent is now only associated on its own with just the accented syllable, which is the second syllable, while the third, the last unaccented syllable, has just the low boundary tone on its own. They're no longer just in the same syllable. It's also important to note here how while the low boundary tone is associated with the last syllable, it seems that they all seem to be starting at different pitches, and the very apex, the very anchor of the boundary tone seems to manifest at the very, very end of the last syllable, which is interesting alignment discussion. Now, still talking about trisyllables, but now talking about non-falling trisyllable instances. We see a similar onset of there being a mid-boundary tone and a high-pitch accent, but now we see the non-falling unaccented last syllable here to be underlyingly low plus high boundary tone, thus causing that very sharp dip. Also forgot to mention, the numbers in parentheses next to each shape is the number of tokens that we have for each shape in our data. Forgot to mention that, apologies. So in trisyllables, so why is it that in our trisyllables, in non-falling trisyllables, we see such a sharp rise, but then in the non-falling disyllables, we don't see the same rise? This is probably due to the fact, and we theorize that it's because that a non-falling unaccented syllable is underlyingly a low plus high boundary tone. But then what happens is when this low plus high boundary tone is then accompanied by a high pitch accent, which would happen if it is also an accented syllable, in order to avoid overcrowding, a similar overcrowding of there being a high pitch accent, low boundary tone, and then, or rather a low starting boundary tone and then the high ending of a boundary tone, this low boundary tone is then delinked. And then what happens is then all that's left is just a high pitch accent and a high boundary tone for accented non-falling syllables. So now we're moving on to an accentual pattern that exists in Ho-Chunk for several reasons, but is a little bit less predictable. This is mainly in instances where, mostly for morphological reasons, specifically verbal morphological reasons, in shapes that start with an H, so in shapes where the first syllable is a heavy syllable, that syllable will actually contain the main stress, the main accent. So we can see this in, for example, nouns. I'll play it again. But it's also seen, again, it's seen very often in verbal morphology due to just vowel coalescence and the combining of several prefixes into one larger prefix, like in this example. Okay, so we wanted to thus compare the pitch patterns of both the initially accented and normally or more predictably accented trisyllables examples with initial H. And what we see is that while there is, again, a general trend of a high pitch accent and a low boundary tone, this low boundary tone seems to be achieved a lot faster, and the dip seems to be a lot more realized in initially accented words compared to the more traditionally accented words that we see with the solid line. And this could be because of several reasons, one of which could be because of a leftward spreading of the low boundary tone from the last syllable, or not necessarily a spreading of this tone, but also just a pre-existing low pitch in the syllable that follows the initially accented syllable in those cases. So now moving on to secondary accents. So moving on to some controversy in Ho-Chunk literature. So Sussman in 1943 described light trisyllabic words, more specifically, to have a secondary accent prior to the accented syllable, which would be the third. And even goes as far to say is that the secondary stress is as strong as, the actual normal stress on the third. But no other source or literature mentions or transcribes this secondary accent, so we wanted to see what our acoustic analyses portray. And what we see is that, for example, we do see a similar trend where the vowel prior to the accented third syllable in these light quadrisyllabic examples in two different intonations, they both have this trend of being higher in pitch than what we would expect if we were to expect a more general movement from the first mid-boundaried syllable to the high-pitched accented third syllable. But we don't. We see actually a pretty similar pitch to the accented syllable. So again, this could be, again, because of a leftward spread of this high-pitch accent onto that syllable, or just because of a pre-existing high-pitched or a higher pitch in that vowel preceding the accented syllable. And same thing like what Sussman originally found or originally proposed with trisyllables, with light trisyllables, there is a similar trend of there being a higher pitch than what we would expect in the vowel following the mid-boundary tone and preceding the accented syllable or the pitch accent. And again, this could be because of leftward spread of this high pitch accent in the trisyllables, or also because we're not necessarily committing to the spreading analysis. It could again also just be because of a pre-existing high pitch in this syllable preceding the accented light syllable or light vowel. So onto another form of disputed secondary accents in Ho-Chunk. It has to do mainly with vowel epenthesis. So vowel epenthesis is quite common in Ho-Chunk, largely because of Dorsey's law, which essentially is a concept that avoids certain consonant clusters by the vowel epenthesis between certain consonant clusters, more namely voiceless obstruent and sonorant clusters. So for example, the word
pere
is actually technically underlyingly pere, and this is seen in sister languages and Siouan sister languages of Ho-Chunk. But Dorsey's law epenthesizes the vowel that follows that vowel cluster and inserts it in between that cluster to avoid it. So these epenthesized vowels was actually described to have a secondary accent by Kenneth Minor in 1979, and thus transcribes these empathetic vowels with a grave accent. Although this has been disputed, including by the speaker Josephine White Eagle, who describes these vowels to be more of a special vowel because of their brevity and not necessarily because of having any specific secondary accent. So we wanted to see what our studies would find. So as we can see here, when we compare just light normal disyllables to these empathetic disyllables, which pere would be an example, like in the last slide. And here we have D that represents the empathetic syllable, standing for Dorsey's law. We see that there is a general trend of the empathetic vowel being slightly higher in pitch than its lexical short counterparts or light counterparts. This similar trend is also seen when we compare disyllables, or rather when we compare trisyllables of these varying combinations. Here in the first syllable, where the first syllable is empathetic, it does seem to be higher in pitch overall. And while not as apparent, or not as not as apparent, we do also see an overall higher pitch in the second empathetic vowel in the second syllable with the LDL, the purple line. This example again seems to be higher in pitch overall. This similar trend appears to happen again and again, and it sometimes manifests more as a spiked pitch. So as we see here in H initial trisyllables, the empathetic vowel here is not necessarily overall a higher pitch, but just seems to start from a much higher pitch and then very steeply normalizes. This same kind of spiking in pitch is also seen in quadrisyllabic combinations. And for some reason, LDLL, all of these instances in our studies, in our research, they were all lower in pitch on average. I'm not quite sure why, but nonetheless, this spike still shows in here in the third example, in this line, in the second syllable, that is empathetic, and here where the vowel is also empathetic compared to their light counterparts. So there does seem to be an overall trend in these epenthesized vowels where they are higher in pitch, but we argue that this isn't really a case for secondary accent. If anything, this more has to do with the environment that these empathetic vowels are in, namely following a voiceless obstruent, which can actually raise the pitch. So if we look, we also compared the pitches of monosyllables of varying onsets, namely sonorant and voiceless obstruent onsets. And we see that on average, isolated monosyllables that start with a voiceless obstruent are in general higher in pitch than those with a sonorant onset, which seems to almost lower the overall pitch, the average pitch of the monosyllable. This overall trend is still seen. So when we look at disyllables, so when we look at the two separate syllables separately, depending on their onsets, we see that here the instance of the disyllable, the D, being more aligned with the pitch of the voiceless obstruent onsets of light syllables in the first syllable, which makes sense because that would be the environment of the epenthesized vowel. And then here we see that again, the vowel after the epenthesized vowel here seems to align also again more with that of the sonorant onset light syllable in the second syllable, which again makes sense because that would be the environment of the vowel following an epenthesized vowel because of Dorsey's law. So concluding on epenthetic vowels, there does seem to be an overall slightly higher pitch with these epenthesized vowels compared to their lexical light syllable counterparts. But we don't really argue that this is because of secondary accent, because it shows up even when the epenthetic vowel itself has a primary accent. And this is seen in the quadrisyllabic examples. And it is likely due to the fact that the epenthesized vowel is coming after, or is following a voiceless obstruent, which, as we have seen in our research, overall heightens the vowel regardless of what vowel it is and regardless of what shape it's in. So just to overall conclude, in isolated words, Ho-Chunk words often realize their accents, or they always realize their accents through high pitch. Boundary tones in Ho-Chunk words seem to have two categories, that of being a low boundary tone and a low plus high boundary tone for falling and non-falling examples, respectively. This low and high boundary tone does simplify into just a high boundary tone when it's then accompanied by the pitch accent of an accented syllable, so when it's an accented syllable. And there does seem to be a heightened pitch observed in syllables prior to the accented one, in light trisyllables or quadrisyllable groupings. And lastly, we do observe there to be a comparatively raised pitch in epenthetic vowels compared to just normal light vowels. But we argue that this is more because of the varying onset types and the onset's effect on the nucleus, rather than there actually being an underlyingly secondary accent in the epenthesized vowels. And thank you so much.
Thank you. So now we have quite a lot of time for questions, 10 minutes. So you can either put your questions in the chat box, or please raise your hand, and then I'll let you speak. So while I wait, okay, so there is one raised hand. Okay, so this Samir, can you please unmute yourself?
Hi.
Hi.
Thank you so much for this talk. It's been really fascinating. And I had a question based on, you said you were looking at words in isolation. And I was just wondering if you had any intuition as to what happens when words are in context with other words in larger sentences. Does the boundary tone change? Does the pitch accent change? Any intuitions from what you've seen?
Dr. Hall, would you want to jump on that one?
Hi, I'm Nancy Hall, so I'm the other co-author. So basically, the corpus we're working with now doesn't contain any what I'd call natural speech. Even in cases where she does produce a sentence, she produces it like this. We do have another corpus of recordings from 1959 of different speakers that doesn't contain some narrative material. So we'd love to look at that in the future, basically. And I've been talking to Johannes Helmbrecht, and who's working in the Netherlands, also in Ho-Chunk, about the idea of doing some studies of discourse that he's recorded with modern speakers as well. But I guess the short answer is, at this point, I have no idea. Sorry. But yeah, that's definitely another big gap in looking at Ho-Chunk. There's really been no work on intonation at all.
Thank you very much.
Okay, so let's see if there's any other question. Otherwise, I do have a question, but I want to see if there's anybody else who's asking to speak. I don't see anybody else. So actually, I have a question related to the epenthesis, the effect that you have on the epenthetic vowel. Did you look at how long basically the raising of the F0 lasts? Because usually, if you want to avoid that kind of effect, if it's like, a consonantal induced kind of effect, you can actually measure F0 a little bit later. like 10 milliseconds within the vowel or 15. I was just wondering, if you thought about this and if you've seen, how long, it lasts in terms of, perturbation. If there's any consonantal induced perturbation, usually you have like, a certain length.
Mm-hmm. Well, so I mean, we just kind of categorized it more as just categorizing these syllables, and we looked at them by length, but more just them being length in terms of their light syllable, form, about how we just look at them as a sister form of these light syllables. But we didn't necessarily look with that much detail of the actual length of the protuberance, and then how much that can be, compared to that of light syllables that don't show this accented form or this higher pitched form.
I think in the examples we had, there's some where there seems to be a brief perturbation and then it goes to the level of a normal light syllable. And there's others where the raised pitch actually seems to go all the way through.
Phase, right? Yeah.
We haven't really looked.
Which
we don't really know what would be the cause of that. But one factor we have not looked at yet is the overall duration of the epenthetic vowels. Because one thing that everybody does agree on with epenthetic vowels in this language is that they're extra short. And so we're planning in the future to actually look at the durations of the epenthetic vowels and see if maybe those cases where it seems like the raised pitch persists through the vowel could just be the cases where the vowel is so short that maybe the perturbation just kind of lasts all the way through.
Right. Yeah. I think it's a good idea. I think it's a good idea to look at that. Let's see. So there's something, I think there must be. No, we just have 5 minutes left, but I don't see other raised hands. Oh, no, I see one. Oh, Samir, you have another one?
Yeah, I just have one more question.
Okay, go ahead.
Yeah, I was wondering in terms of like implementing this in terms of some kind of intonational phonological model or something, it sounds like you have a very clear pitch accent that could be like a high star. You have like two different options for the boundary tone. And I'm wondering for the kind of high pitch on the syllable preceding the pitch accented syllable. I forgot if you had said, are you seeing that as a sort of spreading of that same pitch accent, or is it another tone? It's sort of like thinking like Japanese, like where there's a separate kind of boundary tone preceding that.
Yeah, we're not committing to either. We just, for each of those examples where there is a higher pitch than we expected, we would look at it as, we proposed either theory for all those instances. We didn't commit to either explanation fully.
This is actually something where I'd love feedback for somebody who's more familiar with this whole area of phonology as to how we would tell the difference between these two. With the kind of limitations of the data we have, that we just have these words in isolation, how you would decide whether it's spreading or not. So if anybody would like to chime in.
Yeah, I don't have an answer for that, but yeah, that sounds like a really great way to go forward to see, like, if there's a way to see like if the word length gets even longer in terms of on a phonetic level, if you see any kind of variation there versus something that's just phonologically longer with one extra syllable. But yeah, it's really interesting, and thank you for your talk.
Thank you.
Okay, so we have still a little bit of time, just a couple of minutes. I don't know if there's anybody else who wants to ask a question. Let me just see. I don't see anybody else. Let's see. No. Let me see if I have another one. Yeah, no, I cannot. Yeah, actually, the question that you ask about what to do, with the kind of material that you have is a very, very interesting question. I just totally, I'm very empathetic with the kind of, issue that you raise. And I think, that we really need to think about this much more because, it's a problem that I can see this is shared by other people working, on endangered languages, and we have to kind of like put our brains together and figure things out. So totally empathetic with that. Doesn't really help, but we can think about it. Okay, so I think I'm just gonna go on because we're just pretty much done with the time. Yeah, and I don't think it's a problem if I start presenting the next paper. Okay, so the next presentation, next paper is Prominence Effects in Vowel Perception, Testing Sonority Expansion and Hyperarticulation. And it's Jeremy Steffman from UCLA who's going to present this talk. Please go ahead.
Excellent, thank you. I hope you all can hear me okay.
Yep.
Yes.
So to begin, one kind of well-known function, or one thing we know well about prominence, is that it serves to highlight important parts of an utterance, where important might be unpredictable or informationally rich parts of that utterance. And in line with this sort of general conception of prominence, it's been seen that prominence, broadly construed, benefits listeners in discriminating speech sounds and processing speech more generally. Additionally, beyond the sort of highlighting or emphasizing function, prominence also shapes how speakers articulate segmental contrasts in various ways, with acoustic consequences that extend beyond the kind of classic suprasegmental parameters like duration, pitch, and intensity. So we can think of these effects as strengthening the distinctiveness of cues and helping kind of enhance their perceptual salience. Now, of course, we know, as I said, that prominence helps or benefits listeners in speech processing, but the perceptual consequences of these sorts of prominence strengthening effects, as I'll call them, are in comparison relatively not well understood. So this talk is accordingly about how listeners perceive vowel formants specifically as a cue to a vowel category and as a function of contextual prominence. And this will be in light of the ways which we'll overview in which changes in formant structure correlate with prominence in speech. I'll further, in doing this, try to adopt a test case where there are two competing prominence strengthening effects, which will allow us to some extent, explore how listeners prioritize different patterns perceptually. So to begin, I think it's worth remarking briefly how I'm going to conceive of prominence in this talk. Of course, prominence broadly construed is kind of a slippery notion that's often vaguely defined. However, relevant to the present study, I will assume that in a language like American English, speakers designate a given syllable as prominent via placement of pitch accent, and listeners, on the other hand, will perceive a given unit or syllable or part of an utterance as prominent first in relation to its context and as a function of various cues which will bundle together in line and in addition to multiple other pieces of prominence-lending information. So with this in mind, let's consider an illustrative example of prominence strengthening. It's been seen that voiced and voiceless stops show increased differentiation of VOT and closure duration under prominence. And we can see this as kind of helping to enhance cues to the contrast and benefiting listeners in that regard. This is seen additionally as we could say paradigmatic contrast enhancement, or as I'll refer to it here, localized, a highly localized instantiation of hyperarticulation. Now, additionally, with vowels in particular, we can consider another well-attested pattern or influence of prominence strengthening, which is so-called sonority expansion. In this context, the conception of sonority is defined as general openness of the vocal tract, or we could say impedance looking forward from the glottis. And with this terminology, we can say that a prominent vowel is generally produced with quote unquote expanded sonority, that is more open articulation, allowing more energy to radiate from the mouth, producing a louder vowel, which will have stronger harmonic structure, will be a good host for tonal events, and so on. So in line with this idea, indeed, it's been observed that prominent vowels are produced with increased amplitude of jaw lowering, independent tongue body lowering, with acoustic correlates in terms of formants or formant structure of raised F1 and in some cases lowered F2. So with these two forms of strengthening, that is hyperarticulation and sonority expansion in mind, let's consider one particular test case where, at least conceptually, they seem to conflict. So I'll schematize this acoustically in a vowel space, which you see here, with F2 on the X dimension and F1 on the Y dimension. You see here 4 ellipses where 2 vowel categories, E and I, are differentiated by color, and 2 levels of prominence, that is accented and unaccented, are differentiated by line type around each ellipse. So Consider the following. If a speaker's goal or intent is to hyperarticulate a high front vowel, they should overall produce a more closed oral constriction or extreme articulation of the vowel, resulting acoustically in its displacement higher and fronter in the vowel space, which you see schematized here. And notably, previous research seems to suggest that these particular effects are linked more to F2 for these vowels. Conversely, if the speaker's intent is to produce a high front vowel with, we could say, expanded sonority, they should produce a more open oral articulation. That is, with acoustically the vowel displaced lower and backer in the vowel space, but particularly we expect to see more of an impact on F1 in this domain. So conceptually, we can say there are two different ways in which a prominent high front vowel could be strengthened phonetically, and they appear to kind of conflict. So we can ask, what do we see empirically in previous literature? In fact, previous studies, that is looking at American English E and I and high front vowels in other languages, have found various and conflicting patterns. Some studies show there's clear evidence for hyperarticulation, and others show clear evidence for sonority expansion, as well as some intermediate patterns that I won't discuss for the sake of time. Notably, too, within a given study, there's also evident interspeaker variation in which sort of pattern seems to be prioritized by a given speaker. So taking this kind of survey of the literature, we could conclude that it seems to suggest overall high front vowels are prioritized to be strengthened in different fashions by different speakers. And this is in contrast to other vowels, which, for example, for non-high vowels tend to show very consistent sonority expansion effects. So given all this, my particular research questions are, will listeners adjust their perceptual categorization of a vowel contrast, that is the contrast between E and I in American English, which will be cued by F1 and F2 on the basis of contextual prominence? If the answer to this question is yes, we can further ask if, we can ask which acoustic pattern listeners prioritize, and if they vary in this regard, or if different listeners prioritize different strengthening patterns. So to get at this question, I implemented a two alternative forced choice task in which listeners simply categorized a continuum that varied in F1 and F2 as the vowel E or I, that is the vowels in the word seat and sit, respectively. There was a contextual prominence manipulation, which I'll describe in the next slide, and I recruited 38 native speakers of American English to participate over the internet, that is, remotely. My statistical assessment of the results was carried out with a log-link Bayesian multi-level regression fit with uninformative priors and the model structure that you see specified in our code at the bottom of the slide. I will be, in this presentation, just focusing on the main effects of F1, F2, and prominence, as interactions that might be informative were not seen to be credible in this model, but that's something we could talk about during the question period additionally. Okay. The prominence manipulation that I implemented was intended to cue or to convey a contrast in accentuation, which you see here schematically in the two numbered sentences. So as you can see, both sentences are renditions of the words all say X now, where X is that target word that'll be categorized by listeners. And in one, the prominent nuclear pitch accent, or as I will abbreviate it, NPA condition, the target bears the nuclear accent with a fairly typical declarative tune. And in comparison, in two, the non-prominent post-focus condition, narrow focus precedes the target on the verb say, and thus the target is unaccented. So I say these carrier phrases are intended to convey a contrast and accentuation because in practice, the context in which the target words appeared was tightly controlled, and the target words themselves were actually acoustically identical across conditions to preclude vowel intrinsic properties, which would normally co-vary with context, from influencing the listener's perception of the contrast. So the stimuli themselves can be seen here below in 1 second with waveforms and F0 tracks for each condition. So I would characterize this as a kind of conservative or restrained manipulation, changing only context, leaving open the possibility that listeners might not obtain the kind of categorical contrast in accentuation implied by 1 and 2 above. But nevertheless, the kind of contextual phonetic prominence of the target across conditions does vary as intended. And of course, I'd be happy to discuss more about these stimuli and other considerations that went into their design during the question period. For the target sound itself, I constructed a 2-dimensional continuum which varied orthogonally in both F1 and F2. Notably, as a side note, duration did not vary across the continuum, another practical decision, which I'd be happy to discuss more later. You see the continuum here, arrayed in a 2x2 F1 by F2 space, with the E endpoint, as I'm highlighting here in the top left corner, and the I endpoint in the bottom right corner. So this continuum space is arrayed like the vowel space with E in the top left. So you'll note 2 each dimension spanned an equal number of barks. And my hope in kind of pulling apart the continuum in this way was to allow for the possibility that a different acoustic dimension might be differentially impacted or impacted to a different degree by the contextual prominence manipulation. So with these stimulus structures in mind, let's next consider some predictions for what we might expect to see. So first, following the hyperarticulation pattern, shown again at left, if listeners expect a hyperarticulated variant of these vowels, they should overall require higher F2 and lower F1 to categorize a given word in a prominent context as containing E. That is the vowel E. In the present results, I'm going to display listeners' responses in terms of the proportion of E responses which they provide at a given continuum step. So thus, following the hyperarticulation account, we should see the following, which is now shown at right. That is fewer E responses in the prominent nuclear pitch accent condition. That is the leftmost bar in the plot at right, where the y-axis shows the proportion of E responses. This outcome, if we see it, would reflect listeners' expectation of a hyperarticulated variant of these vowels in terms of F1 and F2, and an according adjustment in their categorization of the contrast. So conversely, if we consider sonority expansion, if listeners tune into the pattern attested with that form of prominence strengthening, they should expect, we think, overall lowered F2 and raised F1 for a prominent vowel, and therefore more readily categorize a given target as E, that is mapping more sonorous or ill-like formant values to E in the prominent nuclear pitch accent condition. So this is now shown at right. And we can see empirically this predicts the opposite of the other pattern, that is overall increased E responses in the prominent condition. So we have 2 predictions which would lead us to expect different shifts in listeners' categorization of the continuum. And of course, we can also see if listeners are variable in this regard. Okay, turning to the results. Here you see a plot showing listeners' overall categorization of the continuum, which is pooled by prominence condition. So again, the 4x4 grid is arrayed like the vowel space with that which you saw in the example stimuli for the target sound. And now coloration in each square in the grid shows listeners' proportion of E responses, which are represented on a gradient color scale indicated to the right of the plot. So what we see overall is that, as expected, both formants impacted categorization such that as F1 decreases, E responses increase, and as F2 increases, E responses increase. So this outcome is, of course, not surprising, but it shows that listeners are using the continuum as intended, and that we have some regions of ambiguity in this kind of continuum space in which we might expect to see a mediating influence of context. Turning to the result of contextual prominence, here you see that same 4x4 grid representing the continuum steps and arrayed as it was before. However, this time there are 2 bar plots in each panel with the NPA condition as the leftmost bar, as was shown in the predictions. So this allows us to see how at a given continuum step, prominence is impacting listeners' categorization. If we focus, as I'm highlighting here, on the ambiguous regions of the continuum, we can see a very subtle but consistent result emerge overall. That is perhaps evidenced best in these portions of the plot, overall, listeners are showing decreased or fewer E responses in the prominent nuclear pitch accent condition. This becomes much more apparent as a pattern if we pool all the responses by continuum step, which is now shown at right. And we see indeed a very small but robust and credible effect in the model, whereby as a group, listeners show decreased E responses in the prominent nuclear pitch accent condition, showing that indeed they're adjusting their categorization of the contrast on the basis of prominence, and importantly, in line with the hyperarticulation predictions, which I outlined previously. So, given this, one point of interest is to see if listeners are variable in this regard, in their perceptual categorization, particularly, of course, for the prominence effect. To get at this question, I obtained effect estimates for each individual participant by summing a bi-participant random slope from the model with a fixed effects estimate, which allows us to essentially quantify in model terms how participants are individually impacted by a given effect, and essentially generating model generated Q weights for each fixed effect. These estimates are now shown in the 3 panels below for prominence F1 and F2, where within a panel, a dot represents an individual participant. And the axes, the y-axis shows that estimate for the impact of each fixed effect in the model. So we see first some variability, that is, they're not all clustering in exactly the same place, yet notably all values within a panel are either negative, that is in case of prominence and F1, or positive in the case of F2. This shows that, as estimated by the model, listeners were all impacted by each effect in the same directionality, that is, particularly for the prominence effect, in decreasing the log odds of an E response. So to me, this was particularly notable because it shows a kind of remarkable consistency on the part of listeners in responding perceptually to contextual prominence. Given these estimates, one other tangential point of interest I had was to see if they correlate with one another, and if that can tell us anything about listeners' use of these cues. Here you see the absolute value of these estimates for, at left, F1 on the y-axis, and with the prominence effect on the x-axis, where each point again represents an individual participant, and the color and size of a point also represents the size of the prominence effect, where a larger color, lighter point is a larger effect. So I just simply correlated these two things, and we can see a weak positive correlation between F1 and prominence. In contrast, looking at F2, we see a robust positive correlation between the effect of prominence for a given participant and their use of F2 as a cue to the contrast. This patterning or correlation is consistent with the previously documented prevalence of F2 as manifesting hyperarticulation for these vowels. And in that sense, it shows that listeners who use F2 more as a cue to the contrast are more tuned into the prominence effect, that is, expecting F2 to change more as a function of prominence. So though, kind of to my surprise, these bi-participant estimates didn't show variation in terms of the directionality of the prominence effect, they do show that the way listeners weight formant cues patterns with their use of prominence lending context. To summarize, what I've shown you today is that listeners indeed shift their perception of formant cues on the basis of contextual prominence, showing very generally that prosodic prominence influences not only, say, the ease at which listeners process speech, but it also mediates how they map acoustic cues to a given segmental category. And we've seen more specifically that listeners expect acoustically hyperarticulated variants of high front vowels in prominent contexts. Of course, questions remain. One big outstanding question for me is why precisely these perceptual effects are so consistent. In the production literature, we've seen that I briefly overviewed, we saw variation in which forms of prominence strengthening are prioritized across speaker. And in the perception results in this study, we have a quite uniform expectation of acoustically hyperarticulated variants of vowels under prominence. So I'd like to conclude with some further directions, which primarily revolve around my interest in kind of in exploring how these, or why these perceptual effects are so consistent, and more generally, how flexible they are. So one line of work in this vein that I think could be interesting would be trying to decrease or override the effects seen here via, for example, an exposure phase prior to stimulus categorization. So we could ask, do listeners still adjust their perceptual expectations in this way, given evidence that a speaker does not evidence or produces pattern themselves, or perhaps shows the opposite pattern consistent with sonority expansion? I think a related extension could tap into the same idea by seeing if listeners maintain speaker-specific expectations for these variable strengthening patterns, which to me seems like a very pertinent question given the previously observed speaker variation in the literature. So relatedly, I think a more general kind of extension could tap into this idea by seeing how these sort of perceptual effects relate to the segmental inventory, or specifically in this case, the vowel inventory of a given language. So of course, American English has a fairly acoustically crowded front vowel space. So a perceptual expectation of hyperarticulation could be kind of analogous to a perceptual expectation of dispersion in the vowel space under prominence. Of course, other languages do not have such a crowded front vowel space. For example, Tongan with a 5-vowel system where E, a high front vowel, shows robust and consistent sonority expansion effects. So I think a kind of targeted cross-linguistic comparison in this vein would allow us to see how these effects relate to the vowel inventory of a given language and the prominent strengthening patterns for the vowels in that language undergo. So my hope is that extending these findings along these lines will help us better understand how these effects, that is the effect of prosodic prominence, relates to speaker-specific, listener-specific, and language-specific factors, and thus more holistically, how prominence factors into language processing. And with that, I will conclude. Thank you for your time.
Thank you very much. That was very good. We have like 9 minutes for questions. So we have quite a lot of time for questions. Jennifer Cole, can you unmute yourself, please?
Yeah, hi. So thanks, Jeremy. That was really interesting. You can hear me? Can you hear me?
Yeah.
Okay.
Yeah.
Yeah, I have 2 questions. I'm going to put them both out, but you can maybe just answer one and see if other people have questions too. My first question is whether you've thought at all about how duration might interact with these effects of formant variation related to prominence. And my other question was, I think the result was really interesting about listeners kind of prioritizing F2 over F1 in terms of these effects. And I wondered, have you looked at to see whether there's a parallel difference between F1 and F2 in the clear speech data when people have looked at what speakers do to be clear, and Bradlow or Rika Smiljanich's work. And I mean, I haven't checked, but the question arose while I was listening to your talk, or how those effects in hyperarticulation for the purpose of clear speech, do the listeners also tune in more to F2 than F1 there? So 2 questions, you can answer whichever one you like best.
To your second question, I can say simply that I have not, but that seems like a very useful place to look and something I definitely want to look into. For your first question, I have more of an actual answer, which is that I think that likely that my hesitancy in using duration as a cue in this experiment, that is to the continuum, is that I expected it to also impact listeners' perception of prominence for the target sound. In that longer durations are typically perceived as being more prominent for a given segment or syllable or what have you. So I was unsure, my predictions became quickly very, very complicated with how duration might skew the contrast first between E and I, and additionally as sort of a prominence signaling potentially cue along the continuum. That being said, I am going forwards. I think that adding perhaps jointly varying F1 and F2 together instead of orthogonally, and then adding duration into the mix as a cue. With these findings in hand, I feel now more kind of in a position to do that. And it would be interesting to see if the results were, if duration in a phrasal context was interpreted as a cue to the contrast or as a cue to prominence in relation to the phrasal context, as whether something's accented or not. Another kind of tangential thing related to that that went into my creating the stimuli was my concern that changes in the durational context of the carrier phrase would influence perception of the target sound itself as kind of a durational contrast mechanism, which might, if duration is indeed being used as a cue to the contrast, also shift listeners' perception. And I feel like those sorts of effects would probably come to the forefront if indeed, if I use a durational continuum in the stimuli itself. So this is kind of rambling. I hope I'm doing justice to your question, but I think going forwards, yes, using duration would be a really interesting extension, especially with the kind of, with my thinking that it's might serve as a kind of cue to prominence in the phrasal context and also cue to the contrast.
Thank you.
Great. So there's another question from Kanan Bryce. Can you unmute yourself, please?
Yeah. Hi, can you hear me?
Yes.
Yep.
Hi, Jeremy. This is a really cool talk. I was just struck by the fact that you were interested in the consistency in correlation in the model estimates for by speaker use of cues in comparison to the production, the more heterogeneous production data. Do you know if the estimates for the greater heterogeneity in the production data are also model estimated subject estimates of differences, or are they just raw data?
That's a great question. So the heterogeneous production data that I referenced, as it's described in the studies, so I guess there's kind of two levels of heterogeneity. One is in a given study, a general pattern emerges. In another study, another general pattern emerges. Then at another level, within a given study, there's clear interspeaker variation. So I guess it's relevant for the second kind within a study. There, the heterogeneous effects were described very qualitatively, that is not in reference to a statistical model. So in a way, it's kind of a strange comparison to make, but the literature is so varied. I should mention too that the production literature is various methodologies too. It's using EMMA data, acoustic data, and ultrasound data. So there's a huge variation there too in terms of method.
I see. Okay, I guess my thought was just the way that you're using the individual estimates from the model contains the hierarchical shrinkage, which basically reduces noise. I mean, I'm sure you know this, but like that provides a more precise estimate of the correlation, the group level correlation, and therefore shrinks individual points towards that kind of group level correlation. And so that might make things appear to be more uniform or less noisy than just like plotting the correlations in the raw data. And so that's why maybe that could account for this difference between studies, but maybe there are also many other factors that you talked about.
I can speak to that a little bit because I also, though I didn't present, I looked at, I operationalized variation outside of the model in terms of for a given participant, if there were fewer or more E responses, like the difference in E responses across conditions, just that raw data. And with that estimate, in the absence of shrinkage, what I observed was 36 of the 38 speakers favored the hyperarticulation pattern. So the raw data is definitely noisier in that sense, or more spread out, but still not variable to the extent that was apparent in the production literature.
Okay, cool. Thanks a lot.
Yeah, thank you. So I think we just have a little bit more than a minute for questions, and I don't know if there's anybody else. I have a very, very quick question that I might want to ask. What's the magnitude of the modification that you were inducing, if you can say something about it, because I think I saw, sort of like the scheme of, how you modified, the F1 and F2. But can you tell me just very briefly, how much, in terms of magnitude did you change?
How much the formants
Yeah.
changed? Yes, that's a great question. So each step on the continuum, I should just look at the slides to confirm that I'm telling you the right thing. Each step on the continuum varied by 0.6 bark. So a fairly I guess a change for kind of impressionistically, a change in one dimension in one step was pretty subtle. But a change in both dimensions in one step was noticeable.
Okay. But did you follow any specific, what was the hypothesis behind, this particular measure? Did you follow any kind of specific idea, or was it just?
Not really.
Not really. Okay, that's okay.
Anchor the endpoints to be very clear in terms of and to just interpolate in some kind of reasonably sized two-dimensional space.
Okay.
So yeah, in that sense, there wasn't a lot of specific desiderata that I had for the continuum.
Okay. Yeah. Okay. Just curiosity, but I'd like to talk to you about this later because we don't have much time. Actually, we're done with the slot for you. Thanks so much again. So we're gonna move on to the last talk for this session. And the title of the talk is Prosodic Phrasing is Integrated in Segmental Speech Perception, Evidence from the Korean Accentual Phrase. And the authors are Jeremy Steffman, again, actually, and he's going to be the speaker, Sayang Kim from Hong-Ik University, Taeyong Cho from Hanyang University, and Sana Jun from UCLA.
My audio is still good, I hope. Okay, excellent. So to begin this talk, there we go. It's fairly well known that prosodic phrasing fine-tunes how speakers articulate given segmental contrasts, and this unsurprisingly extends to modulating the realization of acoustic cues that are in the temporal domain, by which I simply mean distributed over time, like VOT and vowel duration. This talk, what we're interested in looking at today is how these influences translate into listeners' perception of temporal cues, and this is currently an open question for reasons that I will outline. So to begin in kind of framing why this question is interesting and open, consider one way in which prosodic phrasing modulates how a cue is realized. Most relevant to the present study, it's known that voiceless stops, especially those with long lag VOT, typically exhibit longer VOT phrase initially. And this could be seen as domain initial lengthening or strengthening of VOT, which is of course additionally an important cue for listeners for distinguishing segmental contrasts having to do with aspiration and voicing. So given this, one could ask, do listeners relate information about prosodic phrasing and domain initial strengthening to their perception of a cue like VOT as signaling a contrast in voicing, for example? One directly relevant previous study by two of my co-authors on this talk is Kim and Cho 2013, who addressed this question by manipulating prosodic phrasing and asking listeners to categorize a VOT continuum, which ranged between endpoints cueing a voicing contrast between American English P and B, with, of course, VOT being longer for P. So the to be categorized sound was placed in a carrier phrase, and the prosody of that phrase was manipulated such that this target was cued as being intonational phrase or IP initial, which you see at left, or IP medial, which you see at right, where bracketing represents phrasing. So given this, what they were interested in seeing is if listeners would adjust their categorization of the continuum, evidencing a sort of expectation of domain initial lengthening of VOT and bringing that to bear on the perception of the voicing contrast. So indeed, what they found was listeners required overall longer VOT for a voiceless P response when that stop was IP initial. That is kind of empirically evidencing fewer IP initial P responses, which could be taken to show that listeners are expecting longer VOT kind of via domain initial strengthening that is following an IP boundary, and they integrate that phrasing information with the perception of VOT as a cue to the voice of contrast. So this interpretation of the findings implicates kind of this processing integration between prosody and segmental cues, which would of course be quite interesting. However, we can consider an alternative explanation for this same finding, which I'll outline in this slide. This alternative rests on the fact that listeners' perception of temporal cues in context is very context dependent and shifts as a function of the duration of nearby segments. So this is shown schematically here with the two conditions from that study that I mentioned, where the bars you see represent schematically the duration of, in this case, the rhyme in the word here, that is ear, the VOT of the following stop, and then the vowel after that. So of note, in the IP initial condition, pre-boundary lengthening precedes the target stop, such that there's a longer rhyme preceding that target stop VOT. This should contrastively influence perception of VOT such that VOT is perceived as relatively short in comparison to this preceding lengthened rhyme. And this is crucially in comparison to the IP medial condition, in which in the absence of a preceding phrasal boundary, there's not this sort of pre-boundary lengthening, therefore a relatively shorter rhyme preceding the target stop VOT. So the perception literature tells us that we should expect VOT to sound shorter to listeners in the IP initial condition as a function of this difference in pre-target duration, which is of course kind of the byproduct of phrase final lengthening. So what this predicts is shorter VOT percepts in the initial condition, longer VOT percepts in the medial condition, and therefore fewer P responses in the initial condition, which is in fact the same finding that Kim and Cho obtained. So the takeaway here is on the basis of this difference in duration, we'd expect to see the same effect that Kim and Cho found. Thus, we have two accounts essentially for the same data. In one account, listeners integrate prosodic phrasing with their expectations of how a cue should be realized, in this case, due to domain initial strengthening. And in another account, durational context effects are responsible for what we see. Notably, the second account doesn't implicate prosody processing on the part of the listener because these effects are sort of domain general auditory processing effects. So for us, this is a really interesting puzzle because if we can tease apart these explanations, we can inform our theory of how prosody is influencing speech processing. So our goal in this talk is to circumvent the potential confound posed by varying pre-target duration in adopting a case that allows us to control for contextual duration. We therefore test a smaller phrasal domain, that is the accentual phrase in Seoul Korean, which is cued tonally in the absence of pre-boundary lengthening, and thus allows us to manipulate perceived phrasing with only pitch. So our goal is to ask, does an accentual phrase boundary impact how listeners categorize temporal cues with durational context controlled? And we'll adopt a kind of conceptually similar design to the study Kim and Cho, which I described. So our goal in doing this will be to test if phrasing influences listeners' perception of temporal contrasts in a way that we can say is definitively independent of durational context. Okay, we'll begin by considering some relevant facts about Korean prosody and segmental contrasts. In this study, we adopt Jun's model of Korean intonational phonology, and a small prosodic phrase, the accentual phrase, or AP from this model, is the focus of this study. You see it represented here. It has a domain slightly larger than a prosodic word, and as shown here, is marked by a default tonal pattern of tone high, low, high, where the initial tone is sort of a variable that's dependent on the laryngeal features of the AP initial segment. So notably, an AP final high tone is, which is indicated here by HA, is a very strong cue for an AP boundary in the absence of temporal modulations. So next, let's consider the relevant segmental contrast. As you may or may not know, the Seoul dialect of Korean has a three-way contrast in voiceless stops for which F0 has recently become a Q, that is diachronically, and a minimal triplet exemplifying this contrast at the coronal place of articulation is shown here. So importantly, in this study, we're going to focus only on two of these categories. That is the two bottommost panels. These are aspirated stops, which have long lag VOT and a high tone AP initially, and in comparison, fortis or tense stops, which have short lag VOT, also a high tone AP initially, and a lengthened post-consonantal vowel. So if we simplify things a little bit, we can say that there are two temporal cues which distinguish aspirated stops from fortis stops. That is, VOT is longer for aspirated stops, and vowel duration is longer for fortis stops in relation to one another. So with this in mind, let's consider how both of these cues are modulated by phrasing at the level of the AP. This sort of phrasing is typically seen as manifesting contrast enhancement for laryngeal contrasts in Korean, in line with the Korean's status as an edge prominence language. So accordingly, VOT in aspirated stops is longer in AP initial position, which is shown schematically at left. And in comparison, vowel duration in fortis stops is longer in AP initial condition, which is shown schematically right. So we thus have two prosodically driven modulations of temporal cues. And with these patterns in mind, our goal is to test if and how a change in perceived phrasing impacts how listeners perceive these two cues, VOT and vowel duration, signaling the contrast between these two stop categories. To do this, in our first experiment, we tested listeners' categorization of a VOT continuum, which ranged from an endpoint signaling a fortis velar stop to an aspirated velar stop. We manipulated phrasing, and again, cued only by pitch, which signaled that stop as either AP initial or AP medial. The carrier phrase, which was in both cases a signal intonational phrase, placed the target word as the verb with the meaning of the phrase overall as that's what we inserted or that's what we grew, which you see at the bottommost bullet point here. And at the bottom of the slide, you see schematic phrasing for these two conditions with brackets or parentheses showing AP boundaries, and a question mark in those examples showing the target stop. So of course, in the AP initial condition, the target is preceded by an AP boundary, and is therefore AP initial. In the AP medial condition, it is phrased with the preceding word and is AP medial. So in creating these stimuli, we manipulated the presence or absence of a high tone, signaling an AP boundary, which immediately preceded the target sound that is in the immediately preceding syllable, which you see here with waveforms and overlaid pitch tracks with this syllable highlighted. All other aspects of the carrier phrase were identical, but nevertheless, this high pitch signaled a clear phrasal break, and slightly lower falling pitch in the AP medial condition constituted an appropriate AP medial pitch pattern. So this manipulation, thus with only pitch on the pre-target syllable varying, alters listeners' perceived phrasing of the stimulus and allows us to test if and how they might adjust their categorization of the subsequent target sound. It's also worth noting that the pitch pattern on the target sound itself, that is in the vowel of the target syllable, was realized in a fashion that was contextually appropriate for both conditions, and this is something I'd be happy to go into more detail with later, including other considerations that went into making the stimuli. So with this in mind, let's consider two predictions for how AP phrasing might alter listeners' categorization of both VOT and vowel length. So first, if listeners tune into the pattern attested in AP initial lengthening of VOT for aspirated stops, which is indicated with letter A at left, they should expect longer VOT values AP initially, such that AP initial VOT value is perceived as relatively short due to phrasing context, and thus overall, listeners should show fewer aspirated responses, or conversely, increased fortis responses in the AP initial condition, of course, relative to the AP medial condition. This is one pattern and one prediction we can make. On the other hand, the pattern related to fortis stops, which is labeled B at right, allows us to make a different prediction. If listeners tune into this pattern, that is initial vowel lengthening for fortis stops, which is indicated with letter B, they should expect longer duration values for an AP initial vowel. Vowel duration should thus be perceived as relatively short AP initially, and if it serves as a cue to the contrast, it should cue an aspirated stop, leading to decreased fortis responses in the AP initial condition. Now, importantly, in this experiment, we are manipulating only VOT in the stimuli. So if this pattern emerges, we should expect it to be only at very ambiguous VOT values, which are ambiguous to the extent that vowel duration becomes a strong or useful cue to the contrast. So with these two patterns and two predictions, we can additionally test if perhaps listeners prioritize certain cues as it pertains to how they're modulated by prosodic structure. It's worth mentioning too that, of course, a third possibility is that we won't see any difference across conditions. And this outcome would suggest that indeed durational context is what was responsible for some previous findings, like the ones I went over in the introduction, and thus that listeners are not referencing phrasing in their perception of temporal cues. All right, so for our experiment, we recruited 30 native speakers of Seoul Korean, all of whom participated remotely online, and just simply categorized the target continuum as being a fortis or aspirated stop by key press. And there are 224 trials total. The statistical analysis was carried out with a logistic link Bayesian mixed effects regression model, which was structured with uninformative priors and predicted listeners' categorization responses as a function of VOT, phrasing context, and their interaction. You can see the full model structure in our code at the bottom of this slide. So with that, let's turn to the results. We can begin by looking at the influence of VOT on listeners' categorization, which is here represented with, on the y-axis, the proportion of times listeners categorized a given target sound as fortis, and on the y-axis, and on the x-axis, increasing VOT values from left to right. So what we see is that, as expected, as VOT increases, listeners respond that a target is fortis overall fewer times. This means that, as we'd expect, longer VOT is cueing an aspirated stop to listeners. And we can see there is certainly some ambiguity in our stimuli. That is, portions of the categorization function that are not at the kind of extremes of the plots. And therefore, this is a place we might expect to see an influence of context. This is shown in the slide here, where we see categorization responses, which are now split by AP phrasing, the solid red line representing the AP initial condition, and the dashed blue-green line representing the AP medial condition. So as we can see, phrasing context indeed engenders a substantial shift in listeners' categorization, whereby overall we get decreased fortis responses for an AP initial target. This again, with durational context in the carrier phrase controlled, allows us to eliminate that as a possible explanation for these effects. So returning to our predictions, this outcome is consistent with prediction B. That is that listeners adjust categorization in line with an expectation of AP initial lengthening of a post-stop vowel, such that a vowel following ambiguous VOT is perceived as relatively short, and thus cueing an aspirated stop, decreasing fortis responses. So importantly, this interpretation of the findings rests rather critically on the assumption that listeners are using vowel duration as a cue to the contrast in our stimuli. Therefore, in order to confirm this and extend the results a bit, we implemented a second experiment in which we presented listeners with a modified version of the stimuli from experiment 1, which likewise varied in VOT, and now additionally varied orthogonally in vowel duration in this two-dimensional cue space seen here. So first, the endpoints are shown in the top left and bottom right corner, a long vowel and short VOT signaling a fortis stop, short vowel and long VOT signaling an aspirated stop, with waveforms exemplifying these right. And of course, each gray point you see on the space is a single continuum token, which is varying in these two dimensions. So our goal or our hope was that in using this two-dimensional cue space, we can first observe and confirm that validation combines with VOT as a cue to the contrast. And moreover, with this sort of validation continuum built in, we can test if listeners shift their perception of the continuum, that is the validation continuum, as a function of prosodic context. Our methods were essentially the same as experiment 1, with 32 participants, and the statistical analysis being the same, of course, including this time validation and its interactions in the model. Let's go to the results. We can begin by inspecting how categorization of the continuum varied as a function of VOT and validation. The two plots on this slide show the effect of, at left, VOT pooled by validation steps, and at right, validation pooled by VOT steps. So as we can see, VOT is more or less evidencing an analogous effect to what we saw in experiment 1. And importantly, validation is showing a credible, though smaller effect, as evidenced by the upward sloping line, whereas validation increases, listeners increase their tense stop responses, confirming that indeed they are using validation as a cue to this contrast. I can say that this is particularly the case for ambiguous VOT values, which is not evident in the plots here, but during the question period, we can take a look at kind of more detailed categorization responses if anyone has interest in that. So these findings overall confirm that listeners are using validation as a cue to the stop contrast in addition to VOT. We can moreover see if our effective context replicates, which it does. As you can see here, a credible, though smaller main effective phrasing context is evident, whereby overall the AP initial condition shows decreased fortis stop responses. This, like I said, replicates what we saw in experiment 1, and with the additional clear use of validation as a cue to the contrast, further supports this idea that listeners seem to be expecting an AP initial lengthening of the vowel and modulating perceptual categorization of vowel length as a cue to the preceding stop contrast on that basis. To summarize, we've seen that pitch-based cues to AP phrasing shift how listeners expect temporal cues to be realized, and therefore shift how they perceive a contrast signaled by temporal cues. Interestingly, in our case, this has the apparent restriction to the patterning of validation temporally as a function of AP initial strengthening. As for why exactly validation might be of sort of primary importance in this case, we're not quite sure, but one very general speculation is that vowels are, of course, sonorous and tone-bearing, perhaps simply more useful to listeners in parsing prosodic phrasing, and as such relied on by listeners more as a cue that is computed in relation to prosodic phrasing in contrast to VOT. I also have some sort of additional speculation on this matter that I'd be happy to raise during the question period. What these findings do show definitively is that listeners relate prosodic phrasing to how a given cue should be realized in the temporal domain and independent of temporal context. We could frame prosodic structural features as generating expectations for a cue value, or conversely as serving as a sort of mediating influence in lexical processing when ambiguous cue values activate multiple competing lexical hypotheses. These sorts of models and accounts of prosodic structure exist, and therefore our contribution here is in showing that they should additionally extend into accounting for how listeners process temporal cues in speech, or to put things slightly differently, kind of durational context account of these effects or the previous effects, which I mentioned, is not sufficient, at least in our particular case in this experiment. So going forwards, we hope to kind of complement and extend these findings in several various ways. We first know that AP phrasing is, of course, relevant in other domains of processing in Korean, such as, for example, word segmentation and phonological inferencing. So testing how phrasing jointly shapes listeners' perception of temporal cues and interacts with these other domains might help us understand the ways in which prosodic phrasing is relevant throughout the process of speech comprehension as listeners make decisions about segmental and lexical material. And relatedly, we could test how these effects play out online with measures such as eye tracking, especially for comparison to the time course of other known effects, which we have sort of a fairly good sense of for AP phrasing specifically. More generally, of course, with these findings in hand, we're now more confident in testing other temporal patterns related to both domain initial and domain final prosodically driven modulation of cues in the temporal domain. And so going forwards, we hope to see how in general temporal cues are weighted and calibrated by listeners in reference to prosodic phrasing. And I will conclude with that. Thank you.
Thank you very much. Thank you very much for this talk. So we have 7 minutes for questions, and we have already a raised hand by Chris Geisler. I'm not sure if I'm producing the last name right. Can you unmute yourself, please? Chris? I don't think I have to do anything, but.
Yes. Hi, can you hear me?
Yeah.
Okay, good. It just took a second for the unmute
Okay.
offer to come through. And you got my name just right. Hi, Jeremy. I really appreciate that you just did a double header. And I want to note that. For this one, though, I also want to say that I just really like the visualization of with the grid with the gray dots. I found that for some reason, I'm going to steal that. Anyway, so this was interesting as a study on this phenomenon that's not talking about F0, which was the context in which I've been thinking about Korean all the time. But since you're talking about temporal cues and temporal potentially, well, I'm going to read temporal overlap into this. What have you tried looking at the ratio of VOT and vowel duration?
That's an excellent question. The short answer is no, but that seems to be probably an equally, of course, that's what's kind of being, if we think of the AP initial context as strengthening the contrast, saying that that ratio is getting made differentiated more is kind of this, it falls out from the patterns as I described them, of course.
Right.
And so that's not something that we've looked at, but that seems like particularly explicitly manipulating that ratio in some sort of sensible way seems like a good way to test if perhaps that's kind of more so what listeners are tuning into perceptually, as opposed to the individual cue values, for example. Of course, I have to think about how precisely to kind of tease that apart, but that seems like a very interesting direction.
Yeah, I'm also knitting my brows a little bit just now, thinking about what that would exactly look like. But the intuition I'm going for is right. Are we, if that might get more directly, if ratio might be getting more directly at what the participants are listening for, in maybe, of course, I would say maybe that's because they're listening for just relative timing of gestures or landmarks or something or other.
Right.
Great, yeah. Really great work.
Thank you.
Okay, so we have another question. Danfeng Wu from MIT. Can you unmute yourself, please?
Yeah. Can you hear me?
Yes.
Yeah, thank you for the great talk. I have a kind of a high level question about your framing, and you said how English wasn't a good place to test this, but Korean was because of, you know, pre-boundary lengthening effects in English at intonational phrase boundaries. But I don't know much about Korean. Is the idea that Korean doesn't have pre-AP boundary lengthening effects? And the other question, so from your talk, my impression was you were mostly just taking advantage of the fact that there is boundary tone at AP boundaries in Korean. But English also has boundary tones. So why isn't English a good place to test this?
Yeah, that's an excellent question. So to your first point, empirically, from what I know, there is, it's not certain that there's AP boundary lengthening in Korean. Someone might know better than I, but if there is, it's very small in its scope, or in the extent that it modulates the duration of segments. So if, for me, even though if it does exist, what is clear is that high tone is a good boundary cue in the absence of that modulation of duration. And so this gets to your second question with English. This is what you said was in fact something that I have explicitly tried to do previously, which was to manipulate boundary tones in English with holding duration constant. So I had more or less. I was testing different boundary tones, but in one study I've used a low boundary tone and another kind of low rising, like we could say L minus H% boundary tone. And what I found kind of weirdly and counterintuitively is that a boundary tone in English for an intonational phrase in the absence of temporal modulations doesn't alter listeners' expectations for how something should be realized as a function of domain initial strengthening. But in contrast, it is perceived by listeners as a speed up in speech rate. It's kind of like, oh, I'm rushing through this boundary. I'm going to produce the tonal contour, but I'm not going to lengthen it. And that change in speech rate perception influenced perception of temporal cues, but it wasn't a change. I was able to confirm it kind of having a different, because they predicted different things empirically, that it wasn't listeners perceiving, expecting, say, domain initial lengthening of VOT as a function of that boundary, but rather shifting perception of VOT as a perceived change in speech rate. So I think the kind of issue that gets tied up with this in a language like English, where there's a substantial intonational phrase boundary lengthening, is that by not lengthening something, you're also going to mess with listeners' perception of kind of how quickly the talker is speaking. And so my paper that looks at this really kind of in detail is a 2019 JFON paper, if you want to look at that. But it's yeah, a very thorny issue, I think, especially in a language like English, where the temporal cues are, it's hard to get away without manipulating them.
I see. Thank you. Yeah, that I don't know if I can follow up, but just briefly, why doesn't Korean have that speech rate effect? Is it just because Korean in general doesn't have AP pre-boundary lengthening?
Yeah, that's the idea, is because the lengthening is so subtle, if it does exist, that listeners don't seemingly don't have an expectation, like an AP boundary tone doesn't alter their perception of the speed at which someone is talking, because it's primarily tonally cued. This is also, I should say, a very small phrase, essentially like at the level of the word. So it's a much smaller domain than like the English intonational phrase.
Okay, thank you.
Okay, thanks so much. I had some questions, but we ran out of time, so I'm going to ask them directly to you at some point. Thank you very much for these great talks and for the audience for the questions. And going to say goodbye, and hopefully I'll see you at some point in some conference and not just from home. Okay. Bye-bye, everybody. Thanks for being here. I don't know if Jeremy, can you stay online for a sec?
Oh yeah, I don't have anywhere to be.
Yeah, no, I just, I'm gonna write to you. Maybe I'd like to talk to you at some point, because I want to ask you a lot of things about it's really great work. Really like it a lot. And I've been thinking about, the relationship between, how we actually figure out, the segmental stuff relative to this sort of like computation, online computation of prosodic structure. It's fantastic. I love it. I just had like 2 or 3 questions very quick. Like one thing is about, did you look at individual differences like age? Did you have like a lot of differences in terms of age in the participants? Because like there's this sort of like change in progress in Seoul Korean where they're using pitch, right? Instead of, did you look at that?
Yeah, so that's a great question. We have not, and primarily recruiting people through the university. So I actually don't.
Okay. Yeah, you weren't doing it like you didn't do like the online thing in Korea with Mechanical Turk kind of thing.
Actually, Sayong, my co-author, did all the recruitment, I think, via the subject pools that they have at Hanyang and Hongik University. So probably college-aged people.
Okay. So you wouldn't see much, but I thought it would be interesting to, to sort of like look at maybe age, at some point. That would be cool. Yeah. But I would add, another layer,
Yeah.
And the other thing that I kind of like noticed, which is also kind of interesting, is the fact that the VOT effect seemed to be categorical.
Right.
And the vowel effect was more like linear. And for me, that's, it's really something that, I don't know, do you have any ideas why this is so?
Yeah, that's a great question.
I think, I have some ideas about why this is so, but, I wanted to hear what you think about it.
Yeah, I think maybe if I can screen share, I can show you something that might.
But I don't want to keep you too much if you want to go. I don't know if we have like something else coming up. You know, I don't want to bother you too much. Maybe we can talk later. Let me check the schedule. Do we have the other session coming up right away? I don't even know.
6 or 7 your time, if I'm remembering.
Oh, okay, so we have time. Okay. Yeah.
Actually, I'm not positive about that. Maybe I should double check because I don't want to.
No, but I think you're right. I don't think there would be like one after the other. You know, I just wanted to make sure that I'm not, you know, stopping you from.
Oh, sure. Yeah. Let me see if I screen share this.
Oh, maybe I have to let you do something. Let me see.
Oh, I think actually I can just.
Yeah, I know you can. Yeah, you.
Oh, okay. Can
Yeah.
you see it? So this is like the categorization split for VOT by each validation step.
Right.
And then on the right, categorization of vowel duration
Yeah.
split by VOT step. Yeah, that's a really good, a great question. And my thought right now is that it seems to be just VOT is much more important as a cue to the contrast, at least in this framing, where like the vowel duration is much more apparent at these ambiguous VOT values, but otherwise it's basically at ceiling or at floor, I guess you could say. And that's also, you know, interestingly the case where for vowel duration, the context effect is biggest too.
Right.
So,
yeah, and it's more like it's throughout. That's the other thing that I wanted to mention to you. But I think it's kind of, you know, it's easy to account is the fact that when you were showing the results for the VOT, I mean the overall results, I mean the composite result, the difference is just like around the most sort of like the inner values of VOT.
Right. Yeah.
Not at the Q, because of course, I mean, I think if it's too long or too short,
right,
it's tough, you know, to have an interaction. But there was like something in the middle. But here it seems that it goes all the way, at least in the ambiguous cases. It's not like localized to specific values. It seems to be more like global. I mean, not localized, you know, within the center of the you know. So that's another thing to think about. I mean, there's something going on there. I mean, I have some ideas about it, but I'm not sure 100%. In the sense that, yes, it might be that, you know, one is sort of like a primary cue and the other one is more like ancillary in a sense. But there might be also a question which is more like lower level, something that is more like, you know,